Hello, everyone, and welcome. I hope you are good. All right, so let's get started. Hello, and welcome to a discussion on treatment-resistant SIBO. Everybody's favorite thing, right? And how many people have ever had a treatment-resistant SIBO case? Everyone's putting their hand up now. You have to imagine that out there throughout the world, and those of you that are listening to this, because that's just part of what SIBO is all about. So I thought I'd, start off with I don't know, it's kind of like almost like a complaint here, but really people, let's try to figure out what is this thing called SIBO really in the first place? What does it mean even? And why is it so difficult to treat? And why, like nearly impossible, really, right? Um, so I think starting off, thinking about like the name itself. So when we think of different disease processes, some of them have really strange names, like cancer. What does cancer tell you about the illness? I don't know, not much, right? It's a constellation. It's like, are you a Gemini? No, I'm a Cancer. It means crab, okay? And they named one of the leading causes of death in the United States is crab disease, if you want to translate the literal meaning. So that's not very helpful, is it? Why did they name it crab disease? Well, I don't know. Some of the ancient Greeks thought that these tumors were really hard like crab shells, or they look like crabs, or they were so difficult to remove, they were like crabs, or some people think that because the pincers of crabs really hurt, it kind of named out. Who knows? But anyways, we call cancer cancer. It makes no sense as a name whatsoever. Um, heart disease kind of makes a little more sense. At least in the ballpark of what the problem is. And SIBO is named small intestinal bowel overgrowth. So it tells you where the problem's happening. It tells you what's happening, but it doesn't tell you the process which is creating it. And so I think this really matters. It's not like an idle kind of cute conversation here. It's it's kind of germane to the whole point is that when we name a disease based on a mechanism or a descriptive term like small intestinal bowel overgrowth, then we think that's what it is. When in fact, what is really small intestinal bowel overgrowth? That's the result of a problem. What's the problem? The problem is that the small intestine's lost its normal motility, peristaltic activity is restricted, the ileocecal valve is backed up, the food contents aren't moving through the small intestine. So the food contents are sitting in the small intestine, whether it's because the ileocecal valve is backed up, because the gallbladder is not working, because you got yeast overgrowth, because there's a problem with serotonin. Something's wrong with the motility and ability to contract of the small intestine. So the food is just sitting there. And so the bacteria are having a good time and overgrowing. But it's not about the bacteria. The bacteria are just doing what bacteria do. And so to think of this as a disease or a condition that we need to kill the bacterial overgrowth is missing the entire point of what the problem is. Again, small intestinal bowel overgrowth. What the problem is a mechanical restriction, a mechanical inability for that normal peristaltic action to push through the food contents quickly through the small intestine. So it can get to where? Your large intestine. And what happens in your large intestine? Things slow down and the bacteria proliferate massively by orders of magnitude, by billions of times, right? In the large intestine, a massive overgrowth of bacteria is exactly what you want. That's called the microbiome. You don't want this upstream massive overgrowth of bacteria in the small intestine that clearly causes a lot of digestive distress. Okay, so I just terminology wise, I just want to clarify what we're actually talking about. It's not an infection. It sounds like an infection because it's a bacterial overgrowth, but it's the result of restrictions in peristaltic contraction, right? And I don't know, you have to trust me. You just get your phone out right now and Google, Mayo Clinic, what is SIBO, and read it right off the Mayo Clinic website and see the definition of what this problem is, okay? So anyways, that's the warm up for today, just to pose the question, who am I? If this is the first one of these you've done, that's great. Super excited to be talking to you. I'm Dan Kalish. I have an interesting career trajectory. I've been in practice for 27 years doing functional medicine and loving every day of it. I practiced yesterday and the day before, but not today. Today was a teaching day. I'm still in practice now. I work with patients over the phone all over the world. And I have the great privilege of being able to teach classes, all online now, obviously. But in past years, I was working a lot with the Institute for Functional Medicine. I may have met some of you there. I was at all the IFM events for a couple years on stage, teaching practice implementation with them. I've worked with the Mayo Clinic on research studies about intestinal function, digestive function. Right now, twice a week, I work with Richard Lord, and a lot of what we're going to talk about tonight is based on his theories and his books, looking at the microbiome and the gut. And it's really a great ride that we all have here. What my real job is not doing free stuff like this. My real job is teaching classes that we charge some money for, okay? Then we've got a couple of good ones coming up. We have a lab interpretation boot camp starting April 12th. It's the first time I've taught this material. It's on amino acids and vitamins. I know that doesn't sound super exciting, but it's a really, really, really interesting class. And I've been working on it literally for 4 years. And I'm super excited to be able to launch it. So the first part of that class is Richard Lord lecturing on amino acids and vitamins, and which is like nothing you've ever heard. He's a brilliant scientist. And then we have a series of case studies and vignettes that I'm going to go through to really drill down on how to prescribe amino acids in a clinical setting, how to use vitamins for great clinical effect. And it's a pretty exciting series of courses. We're going to talk about cardiovascular disease, neurological problems, depression, all kinds of stuff like that. Okay, and then in June we have another new class I've been working on for 4 years with both these, develop both these, where we're going to talk about genomics and SNPs and get into how you can see functional expressions of genetic disorders, genetic problems on these labs that we look at every day in our practices, amino acids and fatty acids and organic acids and all that stuff. Okay, and you get 20% off if you use those codes. And you can go to the kalishinstitute.com if you're interested in some of those classes. And at the end of this month, we have a mentorship that's starting, which is the 1-year deep dive program. If you really want to get a practice going, you want to spend a year with a really great community of docs. It meets once a week live. We review labs. We have a massive curriculum that's online that you go through and really start to drill down on how to sell lab kits, how to get patients enrolled in programs, how to interpret lab tests, how to design effective clinical programs, and give you that confidence that you need to, really go out there and do functional medicine full time. Okay, so that's coming up at the end of March. If you're interested, there's a $1,000 discount code down there for you guys as well. Okay, all right. So we're going to talk about treatment-resistant SIBO, and we're thinking that we need to know what SIBO means. So again, to reiterate, SIBO is a problem where the food in the small intestine is not passing through quickly enough because either there's a problem at the other end where the ileocecal valve is, right? The ileocecal valve is the valve that connects the small intestine to the large intestine. If that gets screwed up, food's not going to pass through very well. Just like if your kitchen sink got clogged or something, the water's not going to drain very well. Or you could have a problem with stomach acid, gallbladder producing bile, pancreatic enzymes, yeast overgrowth, or some mechanical problem related to lack of motility in the small intestine itself. Any of these things can conspire in different combinations to cause SIBO. And so if you're just treating SIBO by diagnosing it and then treating it with antibiotics, you're not addressing the underlying cause, which will be either a gallbladder problem, a stomach problem, a pancreas problem, a yeast overgrowth, a motility problem, an ileocecal valve problem, or something like that. So part of successful treatment of SIBO is getting to the root cause of it. Do you sometimes then also need to use antibiotics or herbal antimicrobials? Absolutely, yes. We do that all the time. I do that literally every day in my practice also. But addressing these underlying issues will get you much more consistent results in treating SIBO and much more sort of just patient relief, because it's frustrating when you treat SIBO and it comes right back, right? And patients get frustrated when they do these things and it doesn't work. So again, normal barriers to SIBO treatment being effective. Bioproduction. It's the first one that came to my mind. I was making this list up earlier this week. It may not be the most common, but I would say it's the most commonly missed. So I put it first. So in other words, if you're not checking gallbladder function on every patient, then you're probably missing a lot of people that have bile production problems, Why does that cause SIBO? Because the bile, as it hits the small intestine, has a massive effect on wiping out bacteria. And if you don't have proper bile production, bacteria can proliferate simply because the gallbladder is not working properly. Bile has got a lot of water in it. It could be as simple as a person's dehydrated. Stomach acid has a lot of water in it. It could be as simple as a person's really dehydrated. Believe it or not, some people don't drink enough water, and that can cause these problems. You could, of course, also have all kinds of other issues going on with bile production. There's amino acids like glycine that are required to make the gallbladder work properly. If that's not happening, you have a problem. It could be stress related, so they're not making stomach acid. I mean, there's a lot of variables here. But between bile production, stomach acid production, and pancreatic enzyme production, any one of those or all three of those together is going to allow the bacteria to overgrow. Now, why would stomach acid production? Well, if you eat food, right, and it hits your stomach and your body's making stomach acid, it's like battery acid. It just, destroys everything in its path, including the bacteria that might get in from you, having chewed on some food. Okay, and the same with pancreatic enzymes. It has, the lack of pancreatic enzymes is going to cause problems with the ability to break down and digest the food, and then the bacteria can feed on this undigested food or this food that's sitting in the small intestine for too long. And then I would say when I talk to the experts on SIBO, I'm not like a world-leading expert on SIBO by any means, but I know the world-leading experts on SIBO, and I talk to them all the time because they're my friends. And when I talk to them, I was like, what's really going on here? And it's a dysmobility or a lack of motility, a lack of contractual ability. The small intestine can't pump food through quickly, and that's going to cause a big problem. You could also have disrupted gut immune function, meaning the immune system in the gut is not monitoring things very well. So bacteria just going crazy town because of that. And then you can have inflammatory problems, et cetera, et cetera. So again, bile is antibacterial, stomach acid is intensely antibacterial, pancreatic enzymes really matter. The smooth muscle in the small intestine pushes food down quickly. When that's working right, the bacteria don't have time to grow. They jet through the small intestine, they hit the large intestine, and then they sit in the large intestine, which is basically a huge fermentation tank, right? Your large intestine is designed to encourage bacterial growth. That's what the microbiome is. And if you have slow transit time in the small intestine, you're getting these bacteria to grow out in the wrong place. Okay, the other things also mucin layer, mucosal layer, and again, ileocecal valve. If you don't check ileocecal valves, it's something really important. If you're not aware of how to do that, you can look at, what do they call it? The Upledger Institute visceral manipulation workshops. They teach how to work on the ileocecal valve and release it, because that can be a leading cause for SIBO-related problems. So again, what's the actual mechanism that's happening? Fermentation. The bacteria that should be growing in the colon are growing in the small intestine, and they're having a party, right? Because they love to grow and they will grow quickly. If you ever did a high school biology class and you put something in a petri dish and then you came back the next day and you're like, whoa, I can't believe how much those things grew. That's so crazy. That's happening, but in a bad way in the small intestine, right? You can also have mucosal inflammation. Okay, and either the bacteria can get the inflammation going, or the inflammation can trigger the bacterial overgrowth, and then you've got problems like malabsorption and dysmobility. So I just thought this was kind of funny. It's a really gross kind of picture, but bring the point home here that your stomach acid can dissolve metal. I mean, it's really acidic. So if you've got enough hydrochloric acid, you're going to be able to destroy the bacteria coming in from the food in the first place. If you've got a great pancreas that's producing enzymes and a beautiful gallbladder that's producing enough bile, then you're going to nuke a whole nother bunch of the bacteria right there in the small intestine. Okay, and again, if the gallbladder is backed up, this is probably not the most common reason why I've seen SIBO be treatment resistant, but the most commonly missed reason, meaning that I get a lot of referrals from other patients that have seen other practitioners. They have SIBO, they've had it treated a few times. I'm like, okay, well, we're not going to do a better course of antibiotics or a better antimicrobial herbal program. You've already done that, twice and it didn't work. Maybe there's something else going on, and we do a good checkup and we find that they have a gallbladder issue. Fix that. Does that fix the SIBO? Not necessarily, but then it allows you to finally fix the SIBO once and for all. Okay, I'm not saying that the gallbladder problems are going to cure everything. If you solve the gallbladder issue, at least it opens the door so you can then take care of the SIBO itself. Okay. And oh, I want to show you this study. Let me just pull this over because I thought this was kind of cool. Well, I broke out some slides on it from it. Let me just show you the study itself here. Where'd that go? Oh gosh, that's weird. I pulled it up a long time ago. Huh. Well, that's a little strange. Now my computer is acting on its own. Okay, that's a little scary, because I pulled up this document and now it's not there. All right, I'm not going to get creeped out by that. I'm just going to be a grown-up and I'm going to open it again. And now it's not cooperating. Okay, now I'm a little freaked out that maybe my computer is on to me in some way. Oh no, there we go. There we go. Okay. Sometimes I say bad things about my computer and I feel like it knows it, and that I'm try to, on webinar days, be very nice to my computer and not malign Bill Gates or Microsoft or anything about PCs. Anyhow, from the journal Cell, indigenous bacteria from the gut microbiota regulate host serotonin biosynthesis. So what does that really mean? That means that the bacteria from your gut control your serotonin production. And why does that matter? Because serotonin, one of serotonin's many roles in the body is to make you happy when it's in your brain. However, the majority of your serotonin, as you know, is made by the enterocytes. It's made in the intestinal lining. And one of the things that the serotonin does in the intestines is control peristaltic contractions. Okay, and if you've ever had food poisoning, you know what this is like, because if you've ever eaten a meal, and this happened to me, I lived in Thailand, in a monastery in Thailand for several years, in southern Thailand at a place called Wat Suan Mok, and I studied under a man named Ajahn Buddhadasa, who is arguably one of the greatest enlightened masters of his era. He's dead now, but a wonderful Thai master. And so anyways, I spent 2 years in his monastery. And one of the things that happens when you live in monasteries in Thailand is you get kind of sketchy food once in a while. And so, got really bad dysentery, absolutely throwing up, vomiting, nausea, diarrhea, just like not a good thing. It turned out I had acquired a parasite called E. histolytica. And one of the things that happens when you get E. histo is you just get this massive serotonin dump in your intestinal tract because your body's trying to flush the infection out. And what does that cause? It causes all kinds of motility and massive diarrhea. And I can tell you that can go on for a lot of days to the point where you can't even walk anymore. Okay, so that's a way to remember this. When your serotonin levels are low in the gut lining, it's going to restrict the contraction of the gut, and you can have constipation, or you can have a lack of motility in the small intestine, which is going to then cause the bacteria there, because they're sitting there, to just overgrow. So imagine the bacteria, like in my situation, when you have E. histo and you're having diarrhea every day and you can't walk, there's nothing staying in you, right? The food is just going right through you. You probably can't even eat for a few days anyways because you're so nauseous. But there's no food in the small intestine. It's just getting dumped out. There's this dump of serotonin, there's this dump of food, and the intestines are just contracting horrifically to eliminate everything because you're sick. That's why they're doing that. It's a normal response to getting a horrible infection in your gut. Then remember the reverse, not enough serotonin in the digestive tract, a lack of the ability for peristalsis in the small intestine to work, so the bacteria just sit there. And as we know from our Petri dishes from high school, if bacteria just sit in an area where there's a lot of food for them, they grow and they grow and they grow. And that's kind of the origin of what we're talking about from the SIBO perspective, okay? And so you should test and you should correct serotonin problems in these patients because that might be part of the issue, intestinal motility. And these are just kind of cool little images of the gut lining. You can see the intestinal cells and all this stuff. And serotonin, and there's a little figure here, says serotonin can also act through different mechanisms to influence inflammation. So serotonin does a lot of things besides impacting our mood and brain. It has a very strong role to play in the gut. Has a lot to do with the transport of oxygen. It's a pretty interesting little chemical, right? But that's the main point here, right? So then, here's another article on it, role of serotonin in gastrointestinal motility. in irritable bowel syndrome. So when we're done with the talk, I'm going to look at a couple of cases, and I can show you some more detail on this if you guys are interested. So another common reason why people have treatment-resistant SIBO is because they have another thing going on. They have Cryptosporidium, Giardia, like me, E. histo, blasto, roundworm, pinworm, hookworm. Just pick your worm, right? It could be any of these things. Any of these parasitic infections will damage the gut lining sufficiently that you might have SIBO as a consequence of having picked up one of these parasites. And so part of doing a good SIBO workup is to make sure that the person is parasite free. And that's not the easiest thing to do, right? They're difficult to test for. You really have to know what you're doing. You have to do 1 or 2 or sometimes 3 different kinds of labs to look for these types of parasites. But they're important to rule out. And the treatments that you might do for SIBO may not even touch these infections. And so again, you could be in this cycle where you're having to, retreat the person over and over. And then another feature of all this is that we have the villi sticking up, right? And then we have intestinal crypts, and we have the secretory IgA, or the immune response, in the gut lining itself. And that's very key, it turns out, to being able to fight off any kind of bacterial overgrowth. So if there's damage to the intestinal villi from inflammation in the gut, and if there's any compromise in secretory IgA, again, you're going to have something that looks like this, right? Where the villi are damaged or blunted, and that's going to cause problems. And what's the classic thing that you think of that damages villi? I don't know, the classic thing I think of would be gluten intolerance, right? Because that's a pretty common one. So if that's going on in the patient, then you really have to, think twice about what you're going to do in terms of figuring out their diet and whatnot as part of the overall SIBO treatment, okay? And then, I mean, this kind of goes without saying, but maybe it doesn't, that you have to have a thick mucin layer or mucus layer. You can see the pinky salmon color stuff here. That's the mucin or mucus. That layer needs to be thick to free yourself from damage from intestinal related bugs. And if that layer gets thin and thinner and thinner, you can see how that's happening on the right-hand picture there, then you're going to have some serious problems with the person's ability to have a normal, healthy intestinal tract. And again, if there's inflammation and tissue damage in the intestinal tract, then that's going to result in a whole series of problems, one of which could be SIBO. And I like this phrase, labs to lifestyle. I don't know, I think it's kind of funny or easy to remember. But the idea being that if you want to get the mucin layer to be strong, one of the things you need to do is crank up the dietary fiber so that you can have a more robust growth of the good or commensal bacteria. So if you're low in a short chain fatty acid producing bacteria, this is in the large intestine now, okay, then increasing dietary fiber will boost up the microbiome in the large intestine. But this has a very strong effect on the small intestine as well. We'll talk about that in more detail in a minute. Also, you can test for, you can measure low, short chain fatty acid, right? That's something that shows up on stool testing. You can also test for polyphenols, polyphenol markers on organic acids. And if those are low, those polyphenols are used by gut bacteria to grow, the good ones. So if the polyphenol markers are low, you can give more fruits and vegetables, or you can give polyphenol supplements if you want. And I use a lot of polyphenol supplements for these kind of cases to get the good bacteria in the large intestine to come up. Turns out if you get the microbiome working in the large intestine, sometimes that's also a key to unraveling your treatment-resistant SIBO cases. And when we're looking at GI labs, and again, once we're done with the lecture, we can look at a few labs if we have time, you can break those down into 3 different categories. And this is a little bit misnumbered because there's 2 ones. It should be 1, 2, 3. But anyways, microbiome assessment, GI organs, and how they're working, and then if there's dysbiosis or SIBO or pathogens. So, and you got to correct all of these in an integrated way. Get the microbiome tested and corrected. Fix all the GI organs, the gallbladder, the pancreas, the stomach, the small intestine, inflammation, get all that fixed, and then go after the dysbiosis or SIBO or pathogens. And if you do that in that order, you get the microbiome working properly first with how? Prebiotics, probiotics, and fiber. You then get the GI organs working, which ones? Gallbladder, stomach, pancreas, with bile support, HCl, and enzymes. get all that working, right? And the microbiome working, then you can address the pathogens like the parasites and yeast overgrowth. And if you still have a problem, then you can go after SIBO. I think you'll find SIBO patients will correct in each one of these phases. Some will get better when the large intestinal bacteria are more balanced, when the microbiome is better. Some will correct when the gallbladder, stomach, and pancreas and small intestine start to work better. Maybe you give them some 5-HTP so they make more serotonin, right? So their peristalsis comes back. Or you do something else that helps with intestinal motility. You get the stomach, gallbladder, and pancreas and small intestine contracting properly. That takes care of a huge number of cases right there. And then if that's not enough, you can look at yeast overgrowth, yeast overgrowth or parasites and get those knocked out. And then if that's not enough, then you can treat your SIBO. But I think you'll find a vast majority of SIBO patients will correct at either the first phase here with the microbiome correction, the second phase with the GI organs, or the third phase with a dysbiosis or pathogen-related treatment. Okay, I think you'll find that most of the time. Okay, and just a quick break here for 1 second. I'm going to talk about the classes coming up for those of you that joined late. We have a boot camp coming up, first time ever, part 1 on amino acids and vitamins starting in April. It's 8 weeks, deep dive, very concentrated case-based learning. We're going to go through 4 really difficult cases and teach you all the things that I know about how amino acids work in the body, how vitamins work. We're going to look at depression, anxiety. We're going to look at cardiovascular function and mitochondrial or energy-related problems in there, okay? And then in June, there's a genomics boot camp. First time we've ever done this either. It's connecting the knowledge that we have with SNPs and the understanding of the genetic testing that we can do, linking that to the functional medicine test. So in other words, if you have a SNP for MTHFR, what are the functional tests for folate and how do you interpret those? If you have a SNP for COMT, what are the functional tests for dopamine that you can run, and correlating and connecting the genetic testing with the functional medicine testing. So those 2 courses are coming up. If you're interested, you can go to kalishinstitute.com and sign up. And again, they're 8 weeks. We priced them pretty low, so they're affordable. You get a discount if you sign up with this code, which makes it even more affordable. And I think it's a really great way if you want to develop your lab interpretation skills. Those are really great courses. And I've spent the last many years of my life producing those, so I hope you guys are going to like them. All right, so now back to our regularly scheduled programming. When you stop breathing, what happens? Well, we could all do this for just a minute, okay? Let's say you take a deep breath in, blow all the way out, and hold your breath out. The longest I've ever been able to hold my breath in was 2 minutes. Holding your breath out for more than a minute is really, really hard. Okay, so point is, your body just stops when you don't have access to oxygen for a whole variety of reasons we probably don't need to go into, yeah? However, you want to take that same exact thing. Now we're thinking about the gut bacteria. We're thinking about the first correction here, the microbiome. If you fix the microbiome, you can fix a lot of SIBO people. So what are the bacteria in the large intestine using for food? What's their fuel? What's their oxygen, so to speak? Some of them live on fiber, and they will die if they don't have enough fiber. The short chain fatty acid producing gut bacteria, the good guys in your large intestine, are going to die by the trillions if you don't eat fiber. That's their food. It's like starving them. It's like not letting a human being breathe for a while. Okay. There are other bacteria in the large intestine. These are commensal or good bacteria that produce hydrogen. And they die if you don't have enough of the short chain fatty acid producers. So there are these groups of organisms in the large intestine, ones that break down fiber into short chain fatty acids, another group that feeds on the short chain fatty acid producers byproducts and makes hydrogen. And then there's hydrogen consumers that die if you don't have the hydrogen producers. Now, when these bacteria get into the small intestine and make hydrogen, it's a bad scene. That's right, but that's a location problem. You know, like you could, I don't know. I mean, if you walked into a crowded movie theater and took your clothes off, it would be weird and bad because of the location, right? If you walked into like a sauna at a really nice spa somewhere and you took your clothes off, put on a robe, it would be totally appropriate. It's all location based, right? So if hydrogen producing bacteria cause a nightmare in the small intestine, that's one thing. That's like, you taking your clothes off at a movie theater, not a good thing, wrong location. But those bacteria making hydrogen in the large intestine are essential for human beings to survive. Okay, so it's a location problem. So we don't want to eliminate all the good bacteria because that's what the microbiome is. And in fact, at the top end of the food chain, so to speak, right, are these large, and there's millions and billions and trillions of these organisms, right? There's more than you could ever count. You could imagine. It's like more than stars in the sky or whatever. High abundance commensals, the good guys, are growing away, and different groups of them are breaking down fiber and making energy for your intestinal cells. And then some of them are making hydrogen, and then some of them are consuming hydrogen. Okay, and they're in this little, dance. Short chain, you eat the fiber, the short chain fatty acid producers get produced. Now you're making the hydrogen ones. Now you're making the hydrogen consuming ones. And just say that you don't have enough fiber, it means that the hydrogen consumers are not going to be there because there's no hydrogen producers because it like that, right? So this different interlinked sets of bacteria that are good bacteria in the large intestine. The polyphenols that we need, hang on a second, are produced, are large molecular structures. They're from things like green tea and blueberries and whatnot. And the polyphenols are essential because they're also a food supply for the good bacteria, as is fiber, right? And again, we take fiber. Human beings obviously can't digest it. That's the whole point of fiber, right? But these bacteria can, and from it, they make eventually short chain fatty acids. They make fats. They take fiber, and the byproduct of the bacterial process on that fiber is to crank out a bunch of fat, which is weird when you think about it. Like, you think you could make fat out of fiber? I don't think so. Your body can't even digest it. It's kind of incredible. So you want these organisms in large amounts in a certain place. That's the key point here. And they're not bad. And then why do these bacteria produce hydrogen in the first place? Well, we, like I was doing with my breathing example, we burn oxygen to make ATP. And then we have all this extra hydrogen left over from that process, and that turns into water, right? That's the whole citric acid cycle, oxidative phosphorylation, electron transport thing that we all learned in school, right? We pull in the oxygen, we burn it, we kind of mix it in with the glucose, and we get our ATP or energy. The bacteria in the large intestine are in an oxygen-free environment. Okay, so they have all this hydrogen that's being released as part of their metabolic processes, and so there's no way that they can bind it to oxygen because it's an anaerobic environment there. So clever little guys that they are, the hydrogen just binds to hydrogen and forms hydrogen gas, and then of course fatty acids are also left over from that. It turns out that the hydrogen in the large intestine is like super important. If you don't believe me, you maybe wait another 10 minutes till we're done with this talk, but you can Google hydrogen. Why is hydrogen healthy for the human body? And you'd be like, whoa, I didn't know that. It's super, super important that we have this hydrogen production process going on. It just needs to be in the right place. Okay. The other thing that can happen, and this is like my favorite supplement of the last 10 years, is that if you're having a patient that's struggling with their microbiome, and I would say, I don't think you could have a SIBO case that has a normal microbiome. I don't think that's possible. I don't think you could have a small intestinal bacterial overgrowth and have a beautiful set of bacteria in the large intestine. I don't think that's possible. I've never seen it. I don't think it's possible. I think these two things are linked, okay? And that if you're having a problem in the small intestine, meaning you have a problem in the large intestine, it's very common that they're not going to have enough butyrate. You can test for butyrate on a lab, and all the standard stool test companies that we work with have butyrate. And if there's a problem there, you can give butyrate as a supplement. It just came out as a supplement about a year ago, and it's 1 year and a half ago now maybe. And it's an amazing product for these chronic gut cases. Okay, one of the things you should know about. I just wanted to, for a minute, talk about one bacteria. There's obviously thousands of these organisms. On most of the lab testing that we do, there can be anywhere from 10 to 50 of these commensal bacteria. I just wanted to mention one, Acromancium eusenophilia, because it's a really cool one. And it's the one that maintains the intestinal tract lining mucosal barrier or mucin barrier. Okay, and it's also very strongly associated with metabolic disorders and obesity. Interesting. And in people that are overweight and have alcohol-related problems, turns out that Acromancia levels are pretty low. And in people that have good quality Acromancia, a good thick mucus layer, much healthier with their gut lining. Okay, and so there's ways that you can support all these different bacteria. There's products like berberine that help improve healthy levels of Acromancia. There's products that have prebiotic, natural prebiotic components. You can use butyrate as a supplement. There's lots of different supplement choices. And in fact, we've got a little chart here you can see where there's certain, if you want to get into the nitpicky weeds of this, like you can, if you have deep hydro that's low in a lab, you can use something like chondroitin sulfate to bring it up. But the general rules of thumb are polyphenols from fruits and vegetables or polyphenols from supplements, probiotics, and fiber. And a lot of the companies, I think all the companies that we work with now have prebiotic supplements. You don't have to like research this for the rest of your life. You just have your patients buy the prebiotic supplements and get the microbiome back on track, right? So these are the things that you want to track and fix. Number one, make sure the gallbladder, pancreas, and stomach are working properly. You can do that with a standard stool test from the different companies that we use, right? Number two, make sure that the microbiome is in good shape based on some of these things. If it's not, prebiotics, probiotics, and fiber. And then number three, treat any parasites or yeast overgrowth that you have. So if you deal with the organs that are dysfunctional, gallbladder, stomach, pancreas, if the intestinal tract doesn't have that normal peristaltic action, which is the very definition of SIBO, then you might try something like a serotonin test, measure their serotonin levels with an organic acids test. You can give them 5-HTP. If they have a problem with the ileocecal valve being backed up, you can do some visceral manipulation with them or send them out to someone that does visceral manipulation to get the normal motility back in the small intestine, fix the microbiome itself, and then get rid of any pathogens. And I think you'll find that those issues will either address the SIBO directly, meaning that you don't have to do a separate SIBO treatment, or will allow that SIBO treatment to be successful the very first time. All right, so I'm going to open it up for questions, but before I do that, I'm just going to tell you guys, oh, so I told you about the boot camps already a couple times. The mentorship is sort of our flagship course. It's starting at the end of this month. It's a year-long class. There's a whole intensive curriculum that's posted online. We have live weekly classes that I teach where we review labs with you, case after case after case. It's a pretty cool group of people. I love the doctors there. I mean, it's just a great group. We have the best classes, we really do. I mean, I don't want to say it's fun, but it is kind of fun. It's not fun because people are sick that we're dealing with, but it's fun. It's exciting. Maybe that's a way of saying it. It's really exciting. And I know that the practitioners in the course feel the same, and it's just a really fired up group. And you get, if you want to really grow a functional medicine practice or build one from scratch, you need a community of people. You can't do this on your own, you know? And so that's really what we're trying to provide. And it's really quite an amazing process to go through with everyone. Okay, so let's take a break from that stuff and let me look at the questions. Oh, visceral manipulation, that's the Upledger Institute out of Florida. John Upledger, UP, Upledger. And you can just go to their website and look up, practitioners in your area. What's the connection between the problem and just slow GI system and stress? All of the things that we're talking about are mediated or created by stress. And that's my understanding from having done this job for 30 years. So bad gallbladder function, typically anger, bad stomach acid production, who knows, but just like stressed out of the mind. Bad pancreatic stuff, same thing. Lack of serotonin in the body, it all comes back to emotional stress and spiritual disconnection. All these things do. Now, if you're at the level of a spiritual healer, you can just look at someone and heal them. Then you don't even have to do the labs. But I haven't progressed to that level yet. I'm working on it. Let's see. Is villus atrophy reversible? Absolutely. I've done that with thousands of patients, so that's an optimistic view of things. But if it's complete villus atrophy, then there's a point where the intestine never comes back. But if it's partial, then it'll come back, and sometimes comes back quickly. So yeah, you can do this on a vegan diet, or you can do this on a meat-based diet. It can go either way. Some of my best friends are vegans, and that's not a joke. Well, that sounds kind of funny. Like my spiritual teacher is a vegan. My closest life partner and the love of my life is pretty much a vegan. I eat meat, you know, sometimes, but I kind of keep it to myself. Oh, what markers on the oat test for polyphenols? Yeah, let's look at that. I'm so glad somebody asked that question. Thank you, whoever that was. So let's look at some labs. So here, let's pull this up. All right, you ready for this? So this is from Tuesday's class, Tuesday's mentorship class, fresh labs, brand new. Now, if you were in the mentorship, you would be looking at this kind of a thing every day, every week, you know, many hours. So doctors ask questions, then we look at cases, and we look at adrenal labs. Ooh, look at that one. I prescribe DHEA and pregnenolone, get the adrenals working again. We have a whole series of protocols for that. And the question that came in was on organic acids. And so this is an organic acids test from Genova. They also have a Nutraval test, which is almost identical. Okay, and now we're going to look at what are the polyphenol markers on this test. What are the polyphenol markers on this test? And let's see here. I'm going to circle them. It's these here. Benzoate hippurate, phenol, see the phenol in there? Phenylacetate, phenyl propionate, parahydroxybenzoate, and parahydroxyphenylacetate. Just as a clue, 3 of them have the word term, the phrase phenol in them. Okay, so if these markers are categorically high, that can be a bad thing and can mean that there's dysbiosis. Doesn't always, but it can. If these markers are extremely low, it means there's not enough polyphenols in the diet for the good bacteria to live on. So polyphenols, again, they're large molecular structures. We cannot absorb them. All those years of eating blueberries in my smoothie, and I thought I was going to the organic market, farmer's market, and you look at the guy, and it's like, oh my gosh, $12 for the blueberries. And every week I think, oh man, that's expensive. And then but then I think, oh no, I need the polyphenols, I need the antioxidants. So I always buy the blueberries, even though they're expensive. I like them, but they're expensive when they're organic, right? And you get home and you make your smoothie. All these years, I thought I was doing that for myself. No, it turns out I can't, as a human being, absorb the polyphenols from the blueberries. But guess what? My gut bacteria can use them as a food supply. So the next time you drop 10 or 15 bucks on a big thing of blueberries, it's an expense for your bacteria to grow better, not a personal thing for you. How crazy is that? So again, these markers here are the polyphenol markers. If there's a pattern where they're quite low, and this one, let's see, 1, 2, 3, 4 of them are quite low, that's a person that's probably not getting enough polyphenols from fruits and vegetables in their diet. Okay, and that's a really big problem. And let me just show you one other thing here before I forget. Let me try to find, okay, Ashley sent in, here's another adrenal lab. So most of the cases, doctors will send in 2 or 3 labs. Here's another organic acids test. Let's look at the polyphenols in this one. Here, oops. Oh, those are all okay. Well, there's 2 that are low, but there's not a pattern where they're all low. Okay, so that's a better one in terms of polyphenols. But I just want to find, here we go. So this is a GI effects test from Genova, and you can see they measure short chain fatty acids. If they're low, you can give butyrate, okay? And that's, huge kind of benefit for patients. You can really make a big difference with that. All right, so let me see here. A couple other questions that we still have time for. Yep. What to use for increased bowel motility? So usually look for serotonin markers, right, on organic acids, and give 5-HTP if it's appropriate. Sometimes you can use magnesium. I just do it based on the labs, basically. So if someone gets worse from fiber or someone gets worse from probiotics, then clearly don't want to use them, okay? And so usually what we'll do in that case is go for the killing of the yeast or parasites first, and then come back around and see how they're doing, okay? So you don't always have to treat in that order. And if the fiber or prebiotics or polyphenols are making the person worse, you just immediately stop. Sometimes even amino acids can make someone with really bad SIBO worse, okay? Let's see. So in terms of SIBO testing, you want to run these other labs as well, right? So you want to run parasitology workup, yeast workup, organic acids, adrenal programs, all that. Let's see. Just going through the questions here. I'm just reading. I'm sorry, it's taking me a minute. A specific brand of pancreatic enzymes I recommend. So I use FullScript for all my online dispensing, and I use Pure Encapsulations products and Designs for Health products almost exclusively, and I use them interchangeably depending on who's got what in stock. Since COVID hit, there's been a lot of back orders, and so you don't always have everything that you need, But anything from either Pure Encapsulations or Designs for Health in terms of enzymes is going to be great. And then you can basically, you're trusting the company. You don't have to research individual products too carefully. And definitely don't do things that make people worse. Yeah. So if they have a major yeast overgrowth or gallbladder problem or parasitic infection, which is often the case, then you want to treat those first. Or if they have a horrific reaction to dairy or gluten or nightshades, you got to clean up the diet first. Yeah. So there's many vegan sources of gallbladder support. All the companies will have plant-based stuff for you. You can look around, you can find that easily, okay? Does removal of the gallbladder affect SIBO? Absolutely, that would make it more likely it might happen. So top herbs for killing this stuff. I personally like berberine a lot. I use oregano oil extract all the time, like almost everybody. That's a really good one. And then artemisia or some products that contain artemisia. Those are probably my top three: berberine, oregano, and products that are either pure artemisia or have some artemisia in them. And if you again look at Pure Encapsulations and Designs for Health product lines, you'll see they have pretty much all those products. Have you worked with COVID long haulers? Yeah, they're coming in. Not a lot, maybe like 5 or 6 I've had so far. That's a whole nother subject, we could probably do a whole seminar on that at some point, because we're starting to see especially with organic acids testing for mitochondrial function, some pretty devastating mitochondrial problems in people that have had COVID, which makes sense because of the hypoxia influence, right? See, I think we're running out of time. We got another couple of minutes here. I'm going to try to get to all the questions to see. Fiber supplements is more whatever in terms of which are the best ones, whatever they can survive, they don't mind the taste of, and whatever does not cause a lot of bloating, whether it's a psyllium fiber, apple pectin fiber, oat fiber. Sometimes I use other things like diatomaceous earth, other stuff like that that's a little more, kind of off the track. Yeah, and so if you're seeing SIBO patients who really just aren't getting better with anything, think through all these issues. They could have something as simple as a hiatal hernia, a mild hiatal hernia, meaning the stomach is pulled up above the diaphragm, or they could have the ileocecal valve problem, right? It could be purely mechanical. And keep that in mind. Oh, favorite butyrate products. So there's Sun Butyrate from Pure Encapsulations, and there's Tributyrin from Designs for Health. Those are the only high quality butyrates that I know of. The other ones are going to be a little sketchy as to the absorption. It's hard to get butyrate past the stomach and small intestine and into the large intestine. Sun Butyrate from Pure Encapsulations and Tributyrin from Designs for Health get around that whole degradation problem. Okay, most don't. So SIBO is not on my first round of testing because I'm testing gallbladder, stomach, small intestine health and function, pancreatic enzyme levels, parasites, and yeast and polyphenol markers first. And if I can't make any headway, then SIBO would be a later test, but I don't usually do that in my first round of testing because so many times it's coming from something else. Let's see, and then in terms of the testing, there's 3 different companies that I use interchangeably in my practice. There's Doctor's Data that has a new test out as of last year called the GI 360. If you haven't done one of those, you should. GI 360, okay, from Doctor's Data. That's a state-of-the-art microbiome analysis. They measure over 50 of the commensal bacteria, plus they have all the other standard stuff that we're used to, parasites, yeast, stomach function, gallbladder function, all the inflammatory markers and all that, right? Then there's the GI MAP test from Diagnostic Solutions, which has fewer of the commensal bacteria, but a lot of the pathogens. And then there's a GI effects test from Genova. Okay, those are the 3 that I use kind of interchangeably in a way, depending on what's going on and with a patient. Let's see, I think I got through most of the questions here that we have time for. I'm going to wrap it up. I hope you guys are interested in some of these classes. I've spent a lot of time preparing these courses, 4 years, finally releasing amino acids and vitamins. It's not the best title. It's really about fixing depression and anxiety and cardiovascular issues and ammonia detox problems and really getting in and understanding how to work with mitochondrial energy. Okay, that's like a COVID long haul kind of class there, and understanding at a deep level how the vitamins work and how to use effective therapeutic dosages of B vitamins, which I find took me 25 years to learn how to do it. Some of you may benefit from that class. Get a discount, 20% off, which brings the price down to something kind of ridiculously low. And then in June, if you're interested in our other coursework, we have the genomics class. That one's equally exciting. I don't even know what to say about that one. That one is like, what we're trying to do, what I'm trying to do, what my close friends I work with are trying to do is to understand how SNPs can be tied back to the functional medicine tests, right? So when you look at an organic acid, let me just show you an example of this here real quick. When you look at an organic acids test, for example, let's see, we had one right here, didn't we? Here, let me show you an easy one that I've been working on for a while now. So here, this is an organic acids test from Genova Lab. And if you've got an organic acids test and it comes back, and for example, the person has a very high level of L-lactate, like you see on this one, could that be a genetic issue? Absolutely. Is there something called lactic acidureas that are very common genetic disorders in the human population? Absolutely. Could this mean that there's a genetic problem? Absolutely. Could you run some testing, genetic testing and try to figure out more about their need for B vitamins? Absolutely. So this is where it's all heading now, is understanding how the genes relate to these tests. Is there a genetic disorder that leads succinate to build up? Absolutely. What's the solution for that? High dosages of vitamin B2. So understanding those concepts are incredibly important, okay? And I'll show you here a little bit about the classes since we're getting a bunch of questions on them now. So if you go to the Kalish Institute, we've made this very difficult. You click on classes, that was a joke. And then if you click on classes, you will successfully see Lab Interpretation Bootcamp 1, $750, 2 payments of $750 each. You get 20% off. I don't know what that drops it down to, cheap. And then the genomics one, if that's of more interest, same thing, $749 a month for 2 months. You got 2 payments. That drops by 20% if you get the, so what does that mean? You save like $300. The discount wasn't my idea. That was my marketing person's idea. I thought, they were kind of priced appropriately already, but anyways, we lowered the price for you guys. Okay, so I'm gonna wrap it up for today. Great chatting with you. And I look forward to talking with you. Oh, last question here. Those classes are not in the mentorship. No, the mentorship is a whole other can of worms. The mentorship is a practice model that I'm trying to give you with everything that I do in my practice. These boot camps are deep dives into really specific clinical nutrition topics that you're just supposed to know. The mentorship is, the practice model, the clinical model, the patient communication skills, and all that kind of stuff. So the boot camps are separate materials from the mentorship, okay? And can you take the mentorship even if it started? Yeah, absolutely. Well, we hasn't started yet. The mentorship, well, I don't know. Let's see, hang on, let me answer that question. For Sarma there. When does it start? It starts at the end of the month, I think. Let's look. Mentorship, $9.95 a month for 15 months, starts March 29. And we let people in usually for a week or two after it starts. So people start a little late, doesn't really matter. It's a year-long class. You have access to the materials for 2 years, access to the lectures for 2 years. So if you start a few weeks late, it doesn't really matter that much, but the group is starting at the end of March, okay? All right, thank you all, appreciate it. Hope to see some of you in my other classes. Have a great rest of your evening now. Bye-bye.